Now, what we like to do with understanding that we have physical and chemical properties is we like to then discuss, all right, what are our separation techniques? What are we actually going to do to, look at different molecules, different mixtures, different everything that's going on? Now, there are two main methods of physical separation: filtration and evaporation. Chromatography is not as common, but it is one of the methods you can utilize. So don't worry, we won't probably discuss that as much today. We will discuss filtration and evaporation. These two are classified as physical methods as they rely on differences in physical properties of the components of the mixture. So what we want is we use filtration and evaporation to essentially, if we've got a mixture of all these different molecules and we want to separate them out, we use their physical properties to separate them. We go, all right, you have a lower boiling point, you have a higher boiling point. You have a different color, you have this color. You have something else. There's plenty of different physical properties you could use. Essentially, we look at those physical properties and we go, all right, you have this, you have that. How can we break them apart? So essentially, as you can say, these are classified as physical properties as they rely on differences in the mixture. So filtration and evaporation, how do they work? Filtration is about particle size and solubility. Now, solubility is the ability for something to absorb into water, and it is a physical property. So a description: when a mixture is passed through a filter, the insoluble solid is blocked by its physical barrier whilst liquid passes through the filter. So essentially what happens is you'll find that you get a filter. It's like a coffee filter in a sense, and you pour your mixture through it and you want to separate it out. And essentially what you do is you separate your two your solids from your non-solids, and essentially the liquid passes through and it's filtered. Now, evaporation is a really interesting one. There's sort of two main ones. Distillation is probably more common than crystallization, but we'll discuss it very quickly. Crystallization is when you have solids and a liquid, and essentially when the mixture is heated up, the liquid evaporates to form a solid solute. So essentially what happens is the liquid evaporates, and as the liquid moves away, you're left with just solids. You're left with just the crystals that were in the liquid, and that's all you want. So that's what you're really looking for there. Distillation, on the other hand, is where you have two different liquids, and what you do is you essentially just boil these two liquids. So you get these two liquids and you boil them, so they're mixed in together. It's a mixture, so you're essentially boiling one mixture. But you boil off that mixture, and essentially what happens is the liquid with the lower boiling point will evaporate first. It will become, a gas first. And as it becomes a gas, it moves up into a tube. Essentially what it'll look like is like a tube. I hope there's a photo of it. I think there's a photo of it coming up. There is, but essentially it evaporates. I'm going to get that photo up. It's a much better way of explaining it. Essentially what happens is you get this liquid and it boils, and the first component, the one with the lower boiling point, will boil first. Essentially as it does is it boils up and it hits this and it gets pushed down into this tube. Essentially this tube is called a condenser, and what happens is water runs around this tube. So this tube has like a double layer. It's like one layer and another layer. In this outer layer, there is no gas there. The gas from this mixture is in the middle layer. The outer layer is like a pump, and it pumps cold water through it. And that cold water is running around that inner layer, and that inner layer is really cold. So essentially when the gas goes in here, it gets in this really, really cold environment, and immediately it becomes a liquid again. And you've made this tube in such a way it's not going to be able to escape back in there. It's going to go down in here. And essentially, you get this distillation. You get this liquid coming out, which is different to the mixture. It's essentially one component of the mixture. So you keep boiling this, or at whatever temperature it is that the first thing boils, and you keep it at that temperature, and you boil off all of the mixture that was in there of the one part that was at that boiling point, and it should come out as a distilled component, and eventually you'll be left with the perfect amount of what you had of the other component. So that's what that looks like there. Distillation is easily the most common. Distillation occurs with sort of crude oil, which is a raw version of our petrol, something that you'll see a lot. It also happens with things like gins. So if you've ever heard of a gin, and it's an alcoholic spirit, you distill gins a lot, especially with sort of ethanol components and so forth. You also do it with other spirits, but you'll see that that's sort of how that works. Now, there's also some other separation techniques that are slightly different. There's decay-centrifuging. Now, centrifuging is used in medical terms a lot. So me being in sort of medical research, we use a centrifuge to separate blood samples. It's the most common use of it. Decanting, on the other hand, is a little bit different. You essentially use gravity to separate substances. So you use the principle that a lighter substance will float to the top while a heavier substance sinks. And you sort of leave things over a period of time and you look at the density. So you sort of, it's interesting because you sort of leave a mixture, you sort of make a mixture, you get a mixture and you leave it over a period of time in a certain position. And over a certain period of time, they should separate, and you sort of pour out that first part. Essentially, that's how you separate it. Not as accurate as centrifuging. Centrifuging is doing that in a much quicker terms. Essentially, what you do is you spin the sample. So you put a sample in and you spin it. And you spin it really, really quickly. And I think there's a photo of it as I was going through. Yes, this is centrifuging. You put a sample in, and essentially it spins really, really, really quickly. And essentially what happens is the heavier sort of substances end up at the bottom of the tube. They end up further away. And the lighter substances end up more at the top of the tube. And when that stops spinning, you're left with all the heavy content at the bottom and all the light content at the top. And essentially you can, from there, you can essentially go through and pull out everything else that you have there. Now, just quickly, here's some photos of all the techniques. So this would be your filtration. As you can see here, you've got filter paper, you get your residue out, you get your liquid at the bottom. This would be part of your evaporation or your distillation sort of technique. So here's your evaporation. You hope that you sort of end up with a solid at the bottom if you're going to use crystallization. Here's your distillation. And then this is sort of your centrifuging. We didn't really go through, there's no photo of decanting, because decanting there's nothing to do. You essentially just leave it over a period of time. Pretty boring technique, nothing to do. So from here, what's really important to understand is that the percentage composition is something that you would then measure from this. So you've been given essentially the mass of a mixture, and you want to figure out what percentage is one element or one, compound within that mixture. So this is really interchangeable. So as much as this is written in a way that it says percentage by mass, you can also do this in terms of percentage by mixture. It's the exact same technique. So if let's just say, interchange this word of massive compound for massive mixture. So if I had a mixture and I said the mixture was 30 grams, and then I went through either centrifuging or I went through distillation or some other technique. And I'm left with, I pulled out 10 grams of what I wanted, or maybe we'll say 15 grams of what I wanted. And one of the components was 15 grams. I would then put 15 over 30, times it by 100, I'd end up with 50%. So I'd say that 50% of my mixture was whatever it was that I wanted. Maybe it was like a salt or something that I've got out. However, you can also do this by compound. So if you have a compound and you want to figure out what elements are in there, and you use one of the techniques, you'd have to use a different technique, so you have to look at chemicals, but nonetheless, you find that there is 5 grams of this element in there when I had 40 grams of the compound. Essentially, you then go 5 divided by 40 times by 100, and you get your answer you want. So it's really important to understand that as much as that would be, 5%, your terms on this calculation or this formula can be interchangeable. So percentage composition is a really, really useful sort of formulae. Also important that a common mistake is having different units for the denominator. Please don't have different units as a denominator. That wouldn't work very well. It allows us to numerically express how much of a substance is present in a mixture or a compound, essentially what you want to look at. So as you can see here, this is an example. Given that there is 50 grams of copper in a 2.5 kilogram sample of metallic mixture, what is the percentage mass of copper? So this is what we were trying to say just in that last slide. You need to be really, really careful with these questions. You need to be sort of switched on to what is going on. You've been given 50 grams as grams. You've been given 2.5 kilograms. So therefore, you need to be able to interchange those two. You need to say, all right, what is kilograms? What is grams? And sort of mix and get the right one. So you could have done this in kilograms if you wanted to. You could have said, all right, that is 0.05 kilograms. Go for your life. You could have said that. You can also say 50 grams divided by 2,500 grams, which is a much easier way of doing it. I prefer that way over the other way. But beyond that, you do your calculation, times by 100, 0.02 divided by 100, 2%. That's how you go about those questions. So fairly straightforward type questions. I would hope that there's not too much issue with these, but that's sort of how you're going to go about it.